There's typically three types of oil production. Primary production, where oil is produced under its own pressure or with some assistance from artificial lift like pump jacks.
On initial discovery, a lot of oil reservoirs have sufficient pressure to flow to the surface.
What we do in primary is we just deplete the pressure. Good numbers to kind of rule of thumb that, but you produce about 10 to 15% of the oil in primary phase, and then you better go in and repressure.
Secondary production, which is typically produced via water flood, where water is injected into the reservoir and drags the oil with it as the water is going towards the production well.
And so now you got to convert some of those producing wells to injector wells. You tend to bypass a lot of oil because oil and water don't mix. So you're up to 35 or 40% of the oil in place that you produced in primary plus the water flood secondary stage.
Ordinarily, fields were produced on whatever their primary drive is for many years, but in the case of Bell Creek, it was just a few short years before the water flood started. It was generally successful for a period of time, but one of the difficulties with the Bell Creek field is water will move through the high permeability areas very quickly without ever touching the low permeability areas, so it leaves a lot of oil behind. It became fairly apparent that something needed to be done to modify the water flood to try and contact more of the oil that was being left behind.
While the oil boom was winding down at Bell Creek, oil producers in West Texas were learning how to keep oil coming to the surface once production with water injection was on the wane.
And the industry really got its start in the 70s with two large-scale experiments. We're trying to change the properties of the oil so it's more mobile in the reservoir. Neither primary production or secondary did that. That's what's unique about the CO2 is that it does that very effectively.
Oil producers found that injecting carbon dioxide into the oil reservoir increased production dramatically.
The CO2 is highly soluble in oil, whereas water and oil don't mix. CO2 tends to interact with the oil and swells the oil pretty dramatically and make more of it mobile, therefore making less oil left behind than when you water flood.
The oil companies developed large geologic sources of nearly pure CO2 for their oil fields, and CO2 flooding is now standard practice in the oil fields of West Texas.
We buy CO2 from a supplier and we put it in the ground, and over the life of that project, when we're producing the oil, we'll make some of that CO2 back. Well, CO2 is valuable to us. We want to capture it and put it back in the ground in our EOR project, and we retain CO2 in the reservoir.
CO2 EOR keeps the oil flowing in existing wells that would otherwise be abandoned. By working in existing fields, oil production increases without increasing the environmental impact.
Carbon dioxide is a solution to recovering oil that would probably not otherwise be recoverable. Using just conventional technology and water flooding, you will always have a problem leaving oil behind. And I think the CO2 is a real success story.
Since the 1970s, billions of barrels of previously unattainable oil have been produced using CO2-enhanced oil recovery, or EOR.